So today we're talking about two ideas. The first one is proportion equations. Proportion equations are two fractions set equal to each other. Edgar Z, what are we doing, buddy? Cross multiplying. Now I saw people. This really isn't new stuff. Believe it or not, we did this earlier in the year. It's just people on their take-home quiz said we never did this, and I don't. Yeah. Now check this out. We cross multiply. Please, please, please. Whenever you draw this picture, don't drop the equal sign. You must keep it. 45 times 1 goes on one side, and all that other good stuff goes on the other. Whoa. 3 times 2x plus 1. Let's do this. Here we go. Here we go. We are going to distribute. Yeah, now it's an algebraic equation. Now you could use the box method on distributing, or we could just make it rain. Yeah. Here you go. There's our next step. Sulema, great job, girl. Yeah, we're gonna use the property of the additive inverse. We're gonna subtract 3 from both sides. Get that 3. Get that x. Yep. This is 42 equals 6x. That's okay if you got it wrong. Then you'll just do better next time. It's gonna show up on your midterm. Divide both sides by 6, right? What's 42 divided by 6? Come on. Good. My favorite number. There you go. So here we go. Here's problem number 4. I wrote something on the side because it's going to come up at the end of our lesson. You can only cross multiply if there is exactly one fraction set equal to another. If there is more stuff, which you'll see in about 15 minutes, okay? There's more stuff you cannot. Only if it looks exactly like this picture. Yeah? Okay. Yep, we are cross multiplying it up. Boom, cross multiply, boom. You literally probably get a point. The point is actually awarded for you drawing that and then writing this, right? We're going to put 10 times 5k minus 3 on one side. And we're going to put 15 times 5k minus 7 on the other. We're going to go and distribute now, and we're going to solve it. There we go. There we distributed. Now we're going to try and isolate k. What are we going to do next? Yeah, I like it. You could do lots of things next, but that sounds good. Subtract 50 from both sides. Boom, 25k. Edgar, I like it, man. I like it. I like it. He said, let's add 105 to each side. Let's add 105. There used to be a show on TV like 105 and... Oh, 106. Sorry, 106 Empire. I don't know. What's 105 and 30? I think that's 75, right? What's next? What do we do? What? Yeah, you're the man. Yep. We're going to divide by what? Wow, very smart. Very smart. That was awesome. Yep. K equals 3. And then what do we always put around it? Manly cloud. No, but you should, honestly, it helps indicate. You can circle it too. It just helps to indicate, like, so for you yourself, you solved it, that's your answer, that's where it is. Boom. Time to go. Here we go. You ready? What do you do with problems like this? Nice. Well, I want you to know, though, we're stepping our game up with cross multiplying now. Watch what happens. You're the man. Eric, come on. It's time to go, buddy. Okay? Come on. We're focusing up. We're focusing up. There you go. There you go. So that's what it means. Now, we got two choices. Drawing the box takes a little bit more time, and we could totally do that. Or we could just distribute. You know what I mean? Yeah, good. Oh, you guys are so smart. This is going to be m squared minus, oh, hold on one second. Let's use a different color. Let's use a different, I'm already there. I was going to make it a Christmassy type problem with red and green. I was already here. Minus 2m plus 2m minus 4. Here we go. Here we go. Now take a look. We distributed. I just want you to see something. We're going to combine like terms, right? Make sure on both sides everything is combined and tightened up so that we finally get m squared. Negative 2m plus 2m, they both disappear, and here's what you got. That's a big move if you can get to there. Come on. It's time to focus back up. This is the important part. Come on. Take a look. Now look, there's an equal sign between these. You can't combine them. You can't subtract them. You can't do that either. Can't do that. We're not nope. Yes. What's up? We are subtracting. Yeah. Because they're on opposite sides of an equal sign. The same. Yeah. Boom. Watch. Look what takes place. Come on. We are not at our answer stage yet. Yeah. Divide by negative 4. What's negative 4 divided by negative 4? Just 1. No, it's 1. Yeah, m equals 1. How was that? Was that bad? Oh. So, you got two fractions set equal to each other. What are we going to do? Very nice. Very nice. We are cross-multiplying again. Bye. See ya. Come on. Right? Now here's where it gets a little crazy. You literally have to multiply and combine both of them. Okay? Now how do you want to do it? Do you want to do it with the box, or are you happy with just multiplying, distributing? What? The box? Tatiana? Or just do it? Okay. All right, we'll just do it. You ready? So d times d is d squared. D times 7 plus 7d plus 4d plus 28 equals d squared minus 7d minus 3d plus 21. Oh, yeah. Okay. I'm going to combine these like terms, just on these sides. Just tighten it up. D squared plus 11d plus 28 equals d squared minus 10d plus 21. You can't really combine like terms over the equal sign. If you want to think of the equal sign, it's a scale, right? On both sides, it's completely balanced. You know what I mean? So you can take stuff away from one side, but you got to take it away from the other. That's how it works. Sure, yeah, absolutely. Let's start with there. Let's go minus 21 from each side. That sounds like a great suggestion. I like it. It's not people could have done different stuff at this point. Oh, sorry about that. Minus 21. These cancel. I'm left with d squared minus 10d equals 28 minus 21 is just 7 plus 11d plus d squared. Okay. How about other suggestions? Other suggestions. Other suggestions. This is hard, right? Take a look at this stuff. Do you see stuff on both sides that matches? Maybe we could subtract it away. Yeah, very nice, right? On opposite sides, we're trying to get the d's by themselves. Let's subtract d squared. We got the same quantity on each side. Very nice, guys. Very nice. Minus d squared, right? D's take away. We got 11d plus 7 equals negative 10d. Now, what's next after that? You could, hold on one second. When Okay, here's the whole point of this. When you reach a step like this, you need to get d by itself and numbers on another side, right? The best way is the one that requires the least steps. So moving this 11d over to this side over here. You could, but the problem is that if you tried to move the 7 to the other side, it wouldn't combine with the other thing that has a d in it. So 7 equals negative 21d. Now we're still trying to get d by itself. What do we? By. Very nice. Close. No. No. Close. That's okay. If you had a calculator, you would do it in there. What? You see what we got here, right? Watch how I punch it into my calculator. If the 21 were on top, we'd get a nice, easy number. But it's on the bottom, right? No. You divide by negative 21 because you want to get d by itself. So 7 divided by negative 21, 7 divided by negative 21 is, that's weird. Math, very nice. Good, negative 1/3. Yeah, there you go. So we're learning how to do this stuff. Remember that? Remember that day when we worked in our calculator just with fractions? Who knew we were ever going to have to use that? Ready? New stuff, new stuff, new stuff. Okay. You ready? So here we go. So our new stuff for today, our real true new stuff is that there are times and situations when you can cross multiply, and there are times when you cannot. Do you see how in this problem, part of the equation has something that looks like you could cross multiply it, right? Do you see that if it were only just 1x divided by 3 equals 5, we could? Do you see that? If it looked like that, you could cross multiply. It would be so fantastically easy. It would be wonderful. But when they add extra stuff in, like that 1x over 2, you're kind of screwed. Okay? Say to yourself, self, or I'm screwed. Okay? But you're not. You're not, because we've done stuff like this before. This is just a bunch of our skills. We're going to need lots of tools from our box. There are 2 ways to solve this problem. The first way that we could solve it is using something from last week. We could just add the fractions and then cross multiply. Now you can only add 2 fractions if they have the same what? Yeah, the same denominators, right? The same size slices. That's what that bottom number is. Ivan? Wait, hold on one second. Let me just jot this down really quickly. So I've got 1x over, hold on a second. You know what? Let me put it in a color that's the same as on top, so people understand it. I got 1x over 2 plus 1x over 3, and then over here I've got equals 5. Ivan, talk to me, buddy. What am I multiplying by so that they'll have the same bottom? What should the bottoms be? You're the man. So what's this one on the left got to multiply by? Good. 3 over 3. Make sure you're writing both those numbers down. What about this one on the right? 2 over 2. Whoops, that's terrible. I don't know why I wrote that down. 2 over 2. So check it out, right? We're going to practice this tomorrow. Don't get worried. So it's going to be, yeah, we're just going to practice this. So we're going to get, you're going to get 3x over 2 plus 2x over 3 equals 5. Oh, wow, I am just off my mark. This should have been a 6, and this should have been a 6, right? You can. You can. The first thing we're going to do is just combine these, right? Now we have 5x over 6 equals 5. 5 is the same thing as 5 over 1. Then we're going to cross multiply. Right? You get that 5x is going to be equal to 30. And finally, how much is x equal to? X is just going to equal 6. Boom! How easy. Now, who in here thinks that that's a lot of work? Why is it over 5? Over here? I'm just dividing. Sorry. Okay. We're okay? One more and then we're done. So I want you to see something. We're going to do the exact same problem over again, but in a different way because somebody figured out a shortcut that works with all of these problems. And that's, in fact, how you become famous in math. If you can find another way to do a problem that takes less steps, we love you. You're amazing. We'll print your method in a book. So here we go. So here's what this guy slash girl, I'm not sure who it was probably a girl. Girls are known to be very good at math. Okay. Here's what he or she figured out. Here's our original equation. Okay. Here's our original equation. Now, what is the least common multiple of the denominators? What is the LCM of those bottom numbers? Yeah, it's the same number that you would have chosen to combine them. The LCM of these denominators is 6. So here's what he or she figured out. Put gigantic brackets around this when you see an equation like this, right? We can't cross multiply because of that x plus 2 business at the front. Multiply the entire thing through by the least common denominator. Boom.
Wait, why?
Because, Edgar, watch. You get 6x over 2 plus 6x over 3 equals 30. What's 6 divided by 2?
Is there a number for this problem?
It's the same one we just did. This is the same problem we just did, just done a different way. What's 6 divided by 3? What is 6 divided by 3?
6 divided by 3 is 2.
Look how easy it is. No combining, no adding, no cross multiplying. You take all that stuff out, right? You do have to be able to figure out the LCM. Equals 30. X equals 6, right? We have some good people asking questions, and then I'm done for today. Tell me, what were you going to ask? What were you going to ask, Alexis? Okay, good. So that's it. There's 2 ways to do these kinds of problems.